Okay. So the closed loop transfer function of a system is given. This is the closed loop transfer function which is given. So this is the transfer function given, okay, for the closed loop system. The number of poles in LHP and in RHP are. So how many left hand poles and how many right hand poles? That's we are asked to find, right? Again, we'll use this Routh stability criteria. Find this. This is the characteristic equation. Okay, let's write it. S to the power S to the 4. Take this alternating terms 1, 3, 2, then -2, -6, -4. Yeah, so this is the ratio of this. So it looks like these two rows are common or dependent, right? So this will come out to be 0. You can do this math. 3 into this minus this will be 0. And same you can do it here. Again, you will get 0. Right? By the way, it was clearly visible because these two rows were the same. If you remove -2 factor from this, these two are same. So obviously this will come out to be 0. Okay. So how do I solve this? Because to find the left hand poles and right hand poles, I need to find the number of times sign change happens in the first column of this matrix, right? But once we encounter all rows as 0, right? Then what to do? Then what you can do is use this technique where you write the auxiliary, make the auxiliary equation. So when it became 0, right, just the row before that, if you write this equation, right, so it will become -2 s to the power 4 minus 6 s square minus, this is the equation. You take a derivative of this. Okay. By the way, you can remove the common factor just for simplicity, right? It doesn't matter. Right? Just like in matrix manipulation, we can do this kind of operation, right? Take a common factor and do not remove the sign, right? Because the derivative sign will depend on that. Because ultimately what we care about is the sign changes here, right? So sign is important. So if you take this -4s cube minus 6s, right? So this is the coefficient, -4 minus 6. Again, for simplicity, if you want to take out a factor, just take it out. This will ease your calculation. So make it -2 minus 3. Okay. Now we can continue building out this Routh table. This into this is 12 minus 6 divided by -2 minus 3. This into this will be -4. 9 minus 8 is 1 by -3, so -1 by 3. And this will be -4 only. Right? So how many times sign switch has happened? From 1 to -2, this sign changed here once. And then it was negative all the way through. So what does it tell you? So sign switch has happened once, means there is one right hand pole. Okay. Okay, the question here is how many are left hand poles, right hand poles, and how many lie on the j omega axis, right? That means which lie on the j omega axis, this itself, right? It's neither in the left nor in the right. Right, we know it's 1 because one sign change has happened. Okay, now these are all negative. So what it tells you, so all the 4s are actually in the j omega axis. How do I reach that conclusion? I reached that conclusion because I encountered a 0 in between and I had to form an auxiliary equation. So this equation is called auxiliary equation to continue this Routh stability criteria. And whenever you form an auxiliary equation, you can find the roots from this. So you can actually determine not just the location, whether it's in left or right or on the j omega axis, you can actually find the roots and then tell you, okay, these are the poles. So from here, if this equation you solve, right, s to the power 4 3s square plus 2. So whatever roots s square would be, -3 plus minus 9 minus 8 by 2. So -3 plus minus 1 by 2, which is -2 minus 1. So s square is equal to -2 minus 1. This, which basically means there are roots at j and square root of j. So this lies on the j omega axis, right? So these are the 4 roots. Yeah, so So we actually found the location also, right? Not just where it lies. So these are the two roots. You can actually find, now if you have the 4 roots, right, you can actually find the 5th root, which lies on the right hand pole. Although it's not asked in the question, but let's say if it is asked, right, what's the right hand pole? You can find that as well. Let's see how to do that. Okay. So we know that s to the power this was the auxiliary equation, right? S to the power 4. Now I can remove the sign because I can take that common here. So we solved this to get our plus minus j and then plus minus root 2j, right? So means we need to find, so this characteristic equation can be written in terms of this into some factor, and that other factor will give you the right hand pole. So that other factor we need to find, right? How to find that? Divide this by this, right? Easy. So s to the power 4, 3s square plus 2. Let's try to divide this. So it will go by s to the power 5 s into 3s square plus 2s, right? Cancel. Minus 2s to the power 4 minus 6x square minus 4. So minus 2. Minus 2s to the power 4 minus 2 is minus 6x square minus 2 into 2 is minus 4. So this is also cancelled. So this is the another factor, s minus 2 basically. So the right hand pole, which is 2, right? So these are all the poles, j minus j, root 2j and minus root 2j. That's the form of this equation. See, this gives you a one easier way to solve the 5th order polynomial also. Okay, it was easy to find for this one because we got the auxiliary equation and then we could find the four roots and only one root was remaining, so that division could solve that problem.